Hi, welcome back. So we're in Chapter 3, Descriptive Analysis, on the discussion of Bivariate Descriptive. So far, we have accomplished a great job. I think in the previous chapter, we've looked at preparing the dataset from guiding perspective. And then we've taken the first step of analysis in this chapter by looking at the explanatory data analysis in principle. We've looked at the essential tools in order to explore a vector on variable x. We've looked at the distribution, we've looked at the central tendency, we've looked at the dispersion. So imagine you've got now two variables to have something to do with your research. Next is to understand the behavior of both variables, how they are behaving. And this is the study of a bivariate descriptive analysis. So the first step was to study a univariate, which is a single vector. Now we are studying the bivariate, or two vectors at a time. Let's go ahead and have visual presentation to explore what kind of measures we need to capture. So basically in this univariate, we have done three different tools, or we utilize. First of all, we understand the distribution, the central tendency, and then we have looked at the dispersion on each one of them separately. Now, once I take this step to a next level, bivariate relation, well, you might start to think, is there a relationship between them? What kind of a relation, if there is? How are they related? Is one depend on the other? We are trying to capture the kind of relationship. Now, to capture a relationship, one of the possible technique you can follow is by capturing the variation. If you capture how much x1 vary from x2, you might come up with a numerical representative that can tell you, are they related or they are not related. So we are trying mathematically now to quantify the problem. This kind of variation, we call it covariance relationship. So the covariance, it can tell me the magnitude and also the direction of that relationship. When I say direction, what I mean, positive direction, when x1 go up, x2 also goes up. Other way around, when x1 goes down, also x2 goes down. Or maybe completely opposite each other. So when x1 goes up, x2 goes down, or the other way around, when this goes down, this goes up. So this kind of relation, negative one. Also, the covariance can tell you one more scenario, that x1 and x2 has no relation at all. So this is what the study of bivariate can tell me. So they answer a very important question on the relation between two variables, how they are related, how they are behaving, what is the direction of that. Based on the covariance, you will get up with a number, most likely will be from minus infinity to infinity. So we try to standardize this or average this on a single scale that can be more intuitive. For example, I wish to get the number between -1 and 1, something like that, where -1 indicate a negative relation, +1 indicate the positive, and 0 indicate there is no relation. This number is called the correlation. It has the symbol of R. Now, next, what we're going to do, we will start to explore how can we actually capture this covariance. And that's exactly what we're going to do next. I will see you.